Good morning and welcome to Unit 5, Lesson 5.2, Slope-Intercept Form. In our previous lesson, we created t-charts and selected values for x to calculate our y values to graph the line our equations represented. Today we are going to be learning the slope-intercept form. So, the slope-intercept form is a way of writing the equation of a line so that the slope of the line and the y-intercept are easily identifiable. Slope is the steepness of the line. Think of a gentle hill. The slope is very, very small. But if you have a big tall mountain, the slope may be very high. And so when we're talking about the slope of the line, it's the steepness of the line. Now the intercept in the slope-intercept form is actually the y-intercept. It's the point that the line is going to cross the y-axis. And this is important because it allows us a starting point to be able to create our line. So what does the slope-intercept form look like? Okay. Slope-intercept form looks like this. It's y equals mx plus b. Now you're taking a look at that and you're saying that just looks like a big bowl of alphabet soup. So let's break this down. So we have y equals mx plus b. M is the measure or multiple or coefficient of x. So that's what m equals, okay? So when we have m and we place it over 1, we have our slope. Slope is defined as rise, our m, over run, our 1. Now our b term here, and I'm going to circle him here, our b term is our y-intercept. And our y-intercept is at 0, b. Let me highlight this off here. So let's go through an example here. We have an equation that's in slope-intercept form. It's in y equals mx 2x plus 6. So we know from this equation that plus 6 is going to be our y-intercept. So let's go and plot plus 6 on our line. Remember, that's going to be 0, 6, and that's x, y. Okay, so here's 0 for x, and then we have 1, 2, 3, 4, 5, 6, positive 6. That's our y-intercept there. And I'm going to take and circle that so we remember that that's our y-intercept. Now we have our slope here. We have 2x. So this is going to be 2 over 1. Okay? 2 over 1 equals rise over run. So from our y-intercept here at 6, we're going to rise up 2, 1, 2, and then we're going to run over 1. This is a positive 1, so that's 2, 1. And we can go from this point again and go 1, 2, 1. Okay? You can see we're starting to form a line here, but we're out of graph. Well, it so happens that 2 over 1 is equal to negative 2 over 1. 2 divided by 1 is equal to 2. Negative 2 divided by negative 1 is equal to 2 as well. So let's use this as our rise and run. We're actually going to fall down and we're going to move to the left with this. But let's start from our y-intercept. Let's go down 2, 1, 2, and then over 1 to the left. Down 2 and 1 to the left. Down 2 and 1 to the left. And you see what we're doing is we're actually just working the opposite end of the line from our y-intercept. Now we have sufficient points so that we can take and we can actually graph this line. And we can line up our ruler and here is the line for the equation y equals 2x plus 6. Now I'd like you to pull out your personal dictionaries, and I'd like you to add the terms y-intercept and slope. And I'd also like you to add the slope-intercept form and write this equation with the notations on there, so you'll have that as a reference. Once you've finished filling out those sections on your personal dictionary, I would like you to restart the video and we will continue on. Now that you've added those terms to your personal dictionary, let's work through some problems here. So once again, we can take a look and we can see that this equation is in slope-intercept form. We have y equals 2x minus 6. So in this equation, our y-intercept is minus 6. So that's going to be 0, minus 6. So here's our origin. So we're going to move down 1, 2, 3, 4, 5, 6. That's minus 6 right there. Okay. Now our slope is 2 over 1. So from our y-intercept, we are going to move up 2 and over 1 to the right. Because remember, this is y positive, this is y negative, this is x positive, this is x negative. So we're going to rise up 2 and move over 1 to the right from our origin. So we have 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, and so on. So now we have the points, sufficient points, that we can go and we can create or graph this line. So this is the line for the equation y equals 2x minus 6. So let's take a look at the next one again. So our y-intercept is positive 1. The sign stays with our b term. As we saw here, negative 6. This was 2x minus 6, so it's negative 6. This was 3x plus 1. So our y-intercept is 0, 1. And our slope is negative 3 over 1. Okay? So let's find our y-intercept here, 0, 1. There it is. Now our slope is negative 3 over 1. So we're not going to rise up, we're going to drop down because it's a negative number. So we're going to come down 3, 1, 2, 3. The 1's positive, so we're still going to move to the right. 1, 2, 3, 1, 1, 2, 3, 1. We're out of room on our graph. But just as we saw with the other number, what we can do is that negative 3 over 1 is equal to 3 over negative 1. Negative 3 divided by 1 is negative 3. 3 divided by negative 1 is negative 3. So let's use 3 and negative 1. So that means we're going to rise up 3 from our y-intercept. And let me circle our y-intercept here so we know exactly where we started from. So we're going to go up 3, 1, 2, 3, and over negative 1. Up 3 and over negative 1. And what we've done is we've created points on the opposite end of the line from our y origin again. So now that we have sufficient points, we can go through and we can create our line here. And that's the line created by the equation y equals negative 3x plus 1. So we got a couple more here. So let's take a look at the one down here on the bottom left. So we know that our y-intercept is 1. We don't have a measure here. This is just x. So what do? Well, we have to remember that x is just 1x. So our slope is going to be 1 over 1. So here is our y-intercept at 1. And our slope is positive 1 over positive 1. So 1, 1, 1, 1, 1, 1, 1, 1, and so on. 1 over 1 is also equal to negative 1 over negative 1. So we can go down 1, 1 to the left, down 1, 1 to the left, down 1, 1 to the left. And we're just working the opposite side of that line from our y-intercept here at 1. So we can take, now that we have sufficient points, and we can draw this line. And this is the line created by the equation y equals x, or 1x plus 1. So let's do one more here. Once again, our y-intercept is positive 9. Our slope is 3 over 1. So let's find our y-intercept. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 positive. We're right on the edge of the slope here. And we have a positive slope here, so it's 3 over 1. We have no room on the graph, but we remember once again that 3 over 1 equals negative 3 over negative 1. So we can start from our y-intercept here, and we can come down negative 3, 1, 2, 3, and over negative 1. Down negative 3, over negative 1, down negative 3, over negative 1, and so on. So now we have those sufficient points, and we can draw our line. And that is the line for the equation y equals 3x plus 9. So let's do a little review here. The slope-intercept form is y equals mx plus b, where m is the measure, the multiple, or the coefficient of x plus b, and b is the y-intercept, the point at which our line is going to cross the y-axis. Up until now, we've been working with equations that were already in the slope-intercept form, or y equals mx plus b, y equals 2x plus 3. But what happens if we get an equation that isn't in slope-intercept form? What happens if we have an equation like y minus 2x equals 3? When we have a situation like this, we have to balance the equation. When we take a look at this equation, y minus 2x equals 3, it's balanced. We're saying that the left side is equal to the right side. So if we want to get y by itself, we have to remove the 2x from that side and get it over onto the right-hand side. When we think of a balance scale, if we add the same amount to each side, it still balances. If we subtract the same amount from each side, it's still going to balance. If we multiply both sides by the same amounts, it's still going to balance, because it already balances right now. Y minus 2x equals 3. So we need to learn the opposites to be able to balance equations. So the opposite of addition is subtraction, and therefore subtraction, the opposite of subtraction is addition. The opposite of multiplication is division, and therefore the opposite of division is multiplication. They're inverses. So let's take a look at this first equation. Y minus 2x equals 3. Okay. So here's our first equation here. Y minus 2x equals 3. Now we have to think of our equal sign as our balance point. Okay? And remember that whatever we do to one side, we have to do to the other side. So we have y minus 2x equals 3. So we need to get this minus 2x off of this side. So we take a look and we see the opposite of subtraction is addition. So we need to add 2x to both sides. So we're going to add 2x to both sides. Negative 2x plus positive 2x, these just cancel out. So we're left with y, this is our equal line, and we have positive 2x and we have 3. Now we can't combine those two terms, they're not the same. 3 is just a whole number and we have 2 times a variable, an unknown variable. So we can't combine those terms. So y is going to equal positive 2x, and we can drop the positive because it's just inferred, equals 2x, and this is a positive 3 plus 3. So now we have our equation in slope-intercept form. Y equals 2x plus 3 because we balance the equation. So 3, positive 3, is our y-intercept. So we can come and plot positive 3, and our slope is 2 over 1, positive 2 over 1. So we can go 1, 2, 1, 1, 2, 1, 1, 2, 1, and 2 over 1 is equal to negative 2 over negative 1. So we can come down negative 2, 1, 2, 1, 1, 2, 1, 1, 2, 1. And now we have sufficient points to be able to draw our line. So here is the line that was represented by our original equation, y minus 2x equals 3. So let's take a look at balancing another equation here. Once again, our equal sign is going to be our balance line. So we have a positive 3 on this side. We want to get y by itself. We have a positive 3 on this side. So the opposite of addition is subtraction. So we're going to need to subtract 3 from both sides. Minus 3. Once again, the 3's cancel off, and we have minus y equals, and we have 3x and minus 3. We can't combine them, so we have equals 3x minus 3. Kind of looks like we're in slope-intercept form, but we're not. We have a negative y there. We have to remember that negative y is negative 1y. Okay. So if we take and divide all terms by negative 1, negative 1 over negative 1 is going to be 1. So we have 1y. So we can just call that y. We can drop the 1 equals negative 3x over negative 1. 3 over negative 1. That's going to be negative 3 because it's 3 divided by negative 1. We have negative 3 divided by negative 1. A negative divided by a negative is going to give us a positive. So we have plus 3. So now we have this in y-intercept form. We have y equals negative 3x plus 3. And we did that by balancing the equation, by doing the same thing to both sides of the equation. So once again, our y-intercept is plus 3. That's going to be 1, 2, 3, because our y-intercept is 0, 3. And our slope is negative 3 over 1. So from this point, we're going to move down 3, 1, 2, 3, negative 1. 1, 2, 3, negative 1, 1, 2, 3, negative 1, 1, 2, 3, negative 1. And once again, negative 3 over 1 is equal to 3 over negative 1. So we can go up 3, 1, 2, 3, and over negative 3 and 1. I plotted this wrong. Imagine that. I actually made a mistake. Our slope was -3/1, and I plotted -3 over -1. So these points are actually inaccurate. What we wanted was -3, 1, 2, 3, 1, +1. 1, 2, 3, +1, 1, 2, 3, +1, 1, 2, 3, +1. And our inverse would be 3, -1, 1, 2, 3, -1, 1, 2, 3, -1. And we can plot that line. This is an easy mistake to make when you're doing the slope-intercept form, is you can forget to see a negative sign and your slope is going to be opposite of the way it should be. So it's very good to take a look and double check that you know what your rise over your run is, whether you're rising up or falling down, whether you're moving positive to the right or negative to the left. I would like you to pull the worksheet 5.2.2 from your packet. It looks like this. Please pause the video until you have it out and then restart the video when you're ready. All right, you should have your worksheet 5.2.2 out. You'll notice that there are two problems on this worksheet. They both require that these equations be balanced. I'm going to walk you through a little bit of it, but I'm going to want you to try to do these on your own, and then we will circle back and go through them. When we take a look at the first equation, we can see that it's not in slope-intercept form. We have 3y minus 2x equals 3. So you'll need to get that minus 2x off the left-hand side and onto the right-hand side. When you do that, you're still going to have 3y, and this equation needs to be y. So you're going to need to divide all the terms by 3. The problem underneath it is similar but different. We have 1/3 y. It's like y divided by 3 equals x minus 2. So I would like you to pause this video. I would like you to take a few minutes and try to work through these problems. When you get them completed or you get to a point where you can't move forward, start the video again, and we're going to work through these problems to show how to balance these equations and get them into the slope-intercept y equals mx plus b form. Okay, so let's take a look at these equations. Okay, the first equation was 3y minus 2x equals 3. So once again, our balance line is right here. Okay. I don't know why that's so glary right now. I am going to zoom this in a little bit. Oh, wrong button. Make this a little bit easier to see. Okay, so here's our first equation. 3y minus 2x equals 3. The equal sign is our balance line here. First thing we want to do is we want to get this negative 2x off. And we remember that the opposite of subtraction is addition, so we're going to add 2x to both sides. So we add 2x to both sides. This is going to cancel off, and this is going to give us 3y equals, and we have a positive 2x and a 3. We can't combine these terms, so we can write this as 2x plus 3. Now this needs to be y, and we have 3y. So this is basically y being multiplied by 3. So we're going to need to divide both sides by 3. 3 divided by 3 is going to give us 1, or 1y. We can drop the 1, so that's y equals. Now we have 2 divided by 3. So we have a fraction here. It's 2/3 x. And we can leave it like that. We don't have to calculate it out into a decimal. And I'll show you why. And we have 3 divided by 3, so that's going to equal 1. So we have 2/3 x plus 1. So once again, we have our equation now into slope-intercept form. Y equals mx plus b. But you say, what are we going to do with that fraction? Well, we're not going to do anything with it because the fraction is actually giving us our rise over run already. Because if we took this fraction and we put it over 1, it would wind up being 2/3. So when we come up with a fraction like this, it's perfect. We have our y-intercept of 1. So we can take and we can plot our y-intercept, and we'll circle it here so we know where that is. And then we have our rise over our run already because it's in a fraction. We have +2 over +3. So we're going to rise up 2 and over 3. Up 2 and over 3. Up 2 and over 3. And once again, 2 over 3 is equal to -2 over -3. So we can drop down 2 and we can go left 3. So we're going to go down -2 and left -3. Down -2, left -3. So now we have enough points to be able to plot our line. And we have the line that represents, not the best line, the line that represents the equation 3y minus 2x equals 3, or in the slope-intercept form, y equals 2/3 x plus 1. So let's take a look at the next equation here. The next equation is 1/3 y equals x minus 2. Okay, this is our balance line here. This is 1/3 y. This is y being divided by 3 basically. So to get this to be y, we're going to have to multiply all terms by 3. This is basically 1 over 3, and if we multiplied it by 3, that would be 3 over 1. So we're going to take and we're going to multiply 3 times 1/3 y equals 3 times x minus 3 times 2, because we have to do it to all terms. So 3 times 1/3 is going to give us 1y. We can drop the 1 and it's y equals 3 times x is going to give us 3x, and -3 times, or 3 times our -2 is going to give us -6. So now we have our equation in slope-intercept form. Here is our y-intercept, -6, and our slope is 3 over 1. So we can plot this, -6. 1, 2, 3, 4, 5, 6. That's -6 right there. That's our y-intercept. And our slope is 3 over 1. So we're going to come up 3. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. And there are our points to plot our line. And there is the line that represents the equation 1/3 y equals x minus 2, or when it's in its y-intercept form, y equals 3x minus 6. So let's take a moment to review. Slope-intercept form is y equals mx plus b, where our b term is our y-intercept, which is represented by 0, b. That's x, y. Our slope is the measure, multiple, or coefficient of x over 1. If it's just x, we remember that it's 1x. So slope is the steepness of the line. The y-intercept is the point the line crosses the y-axis. The other thing to remember, and I forgot to have you add this to your personal dictionary, is that when we're balancing equations, we need to know the opposites. That the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division, and the opposite of division is multiplication. So you should stop and add these terms to your personal dictionary, and we will see you all tomorrow, where we will expand upon our knowledge of slope-intercept form. That's all for today.